So much, Dr. Parker, for accepting our invitation to be our speaker. And thank you so much to all of you folks who decided to join our talks. We are going to have these talks for whole year around, and we plan the whole semester. And today we are going to listen to Dr. Parker, who is actually a tech graduate. She got her PhD from Georgia Tech, and after that, she got her postdoc in CDC, working in the division of HIV and AIDS prevention. And after that, actually, she got a Fulbright fellowship, and she did a fellowship in Cape Town. And she is right now a professor, an assistant professor in University of Florida. And today we are going to listen to her talking about her research and also her experience as a scholar. Thank you so much, Dr. Parker. The floor is yours, and I will take care of the chat and while you are talking.
Okay, thank you all so much for having me. I'm excited to come back and share some of my story. Let me share my screen here. Okay, get started. Okay, so I titled my talk today, Inspired Innovation, Biomedical Engineering with a Global Perspective. I think that as biomedical engineers, we all want to be inspired in some way. And that's why we chose to be biomedical engineers. We want to help people. We want to come up with new innovative solutions that really have a clear purpose or a clear goal that we can see the outcome of. So I wanted to share just some of my some of the things that have inspired me, as well as just some of the global perspectives that I've gained throughout my training. Right. So in the talk today, I'm going to go a little bit over my background. I think that is a piece of our stories that's often overlooked and actually helps us to understand what has inspired us. I'm going to go through a few specific training points that actually help to shape my passion for global engineering. And Dr. Platt and Dr. Gleason are both part of those stories, major parts of that training. I also am going to talk about a different perspective that I gained of research from a public health perspective at the CDC, a bit about my Fulbright experience, and to kind of give way to what has shaped what I'm passionate about today in the lab that I'm currently starting at the University of Florida. All right, so when we talk about inspired innovation, when I think about people that are gifted or people that are inspiring, I think about people who are gifted in a certain way. The people I've chosen here are people that are very gifted linguists, gifted in writing, gifted in storytelling, right? And they're passionate about the stories that they're telling, the things that they are sharing with the world, right? They have a unique story, a unique background, a lot of pain also in their story, things that they've had to overcome, obstacles they've had to overcome, but also risk takers, right? They were not afraid to kind of put themselves out there and to share their stories with the world. And so I wanted to just put here again, these two that have very much so inspired me just in telling their stories and going against the status quo, really, to share what they have to offer the world with the world, and it being appreciated, even though it was uniquely different. And I want to say also that we all have something here that we're gifted with, right? We all have something we're passionate about. We all have a unique story, and that is all going to be a part of what inspires us to move forward. Right. So how does one become inspired? I think often we forget about Our family's part in that story of inspiration. And I think this is something I definitely picked up from my travels to South Africa, and really understanding how they really kind of reverence those who came before them and kind of pay homage to those. And I think oftentimes in science, we start with, this is what I found, this is where I'm going, but how do we get there? I think those are really important parts to help people to understand, why are you here? How did you get here? And so when I think about myself, I start with my parents, right? My dad, he was an engineer at Georgia Tech. He was one of the first Black students in the first integrating classes at Georgia Tech. And he came and he was an electrical engineering major. He struggled quite a bit, just coming from Montgomery, Alabama, and not having all of the same resources, right? His dad fought for desegregation with the Montgomery bus boycott. So there are a lot of racial tensions that they came through and overcame for him to come to Georgia Tech and be there. But what he passed down to me was just that initial knowledge of actually being in a college situation. So he knew what to tell me, what I needed to study. I was good at math and science. So he pushed me. He pushed me a lot towards engineering, and he told me about the issues that he had to overcome. So I was more prepared as I entered undergrad to be able to overcome those obstacles. And so that is a huge part of my story. I think my mother as well, there were times where we struggled. They were business owners, right? And she also taught me how to be able to share my story through written words, and to be able to look for scholarship money, to be able to look, so that finances would not be a hindrance to us in a way. And that translated to me being able to write graduate fellowships and things of that nature, and just being able to not see barriers or obstacles as something that couldn't be overcome, but something that could be, trying to figure a way around it, right? It's kind of the hustler spirit is what I'll call it, is what I received from them. I also have my community, right? The community that I grew up in, and that also shaped what I was passionate about, the things that I saw that were difficult for that community. And in the back of my mind, those have been things that have shaped, what questions I want to answer and how I want to answer them. Also, professors in training, right? So you could have all this background of your community and your family, but you also have to have technical expertise to be able to answer certain questions or solve certain problems. And so all of these things, along with international experiences, has really helped to shape how I have become inspired. Again, but we all have our own stories of how we've become inspired, how we've gotten to where we are today, and what propels us forward. Right. So I talked a bit about my family, right? The community that I grew up in, a lot of people's parents had not gone to college, right? So, I saw that with the limited resources I had, I would go to the library to study for the SAT and get the books and take the tests, online that were free, but many of my peers didn't have those opportunities. And so even there, I began to see privilege, my own privilege compared to my peers, as well as being able to become really inspired and passionate about using what I had to help others. So it was, hey, I can get this SAT book and I can start an SAT prep class, like, which is what I did with the students in my class, and helping people to write essays for college. Again, I had my parents to help me; they didn't really have that. And so if I think of one time the first time when I was really inspired to actually do something that required a bit more effort from me, it would be this instance here, kind of seeing that I had resources, or I had access to things that others didn't have, and trying to leverage that to be able to help, or come up with a program or something to be able to help others in need. Right. So from there, from high school, I transitioned onto the University of Florida, and I majored in mechanical engineering at the University of Florida. And it was pretty much do or die once I got there. And you're trying to really just learn all these new engineering concepts, and put them together so that you can kind of see what your end goal is. And for me, it was hard to kind of see that until I got to my senior design courses, where I was able to see this is how you put all of this together. And that was what really excited me. But while I was there, getting this foundational knowledge, I came in contact with Dr. Jonathan Earl, who was the assistant dean at the time, and he had a program that was called step up for students that came from, let's say, disadvantaged backgrounds, right? Because the retention rates were very low for students in engineering at this time. And so through this program, I saw how him as a position, uh, 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 as an assistant dean or just as a professor, was able to leverage the resources of the university to put into making sure that students that came from maybe not the most level playing fields actually had a chance to survive or thrive in these areas. And it didn't stop just there. It was also, I saw him working in the high school areas with STEM and trying to understand and making sure that students from low income areas were exposed to STEM in a way that they could understand it, in a way that was exciting to them, in a way that actually pushed them to pursue STEM majors or just go to university at all. And so this, I think, my biggest takeaway and inspiration from this point, because I think it was the surviving mostly, but was that, okay, if I can become a professor or if I can become someone that is in academia, actually I have the weight of the academic institution behind me. So if there are other things I want to do, outside of teaching and research, I actually also can leverage that. And I had never seen that or really been exposed to that before, but that was something that I really saw while I was at the University of Florida. Right. So again, I'm just building these things that have shaped who I am and why I'm inspired today. Right. So Georgia Tech was the next step in that training, right, or that journey. Within the undergraduate program of mechanical engineering, I realized, this is cool. It might give me a good job, but it's not something that I would want to pursue a PhD in. It's not. It wasn't really pulling at my heartstrings. It wasn't necessarily something that I could see myself being very passionate about. And so I discovered the bioengineering program at Georgia Tech. And that actually really got me. I was very excited about much of the research in these areas. And specific to me, the research that I did there was kind of trying to understand how HIV proteins, as well as the antiretrovirals that patients take, um, can contribute to increased cardiovascular risk or cardiovascular disease that's seen in patients living with HIV, right? So I worked with Dr. Platt and Dr. Gleason, and I did this work through various different models, right? I learned a lot of molecular biology techniques, was able to use mouse models, uh, in vitro cell culture systems, and also clinical samples as well, right? To really answer some deep questions. And this was no small feat for me because, again, coming from a background of mechanical engineering, I had maybe taken biology in high school, right? So this was a huge part of, again, me being able to really understand, because I needed to be able to understand basics in the language and just all of the technology that was available, the techniques that were available, again, to answer future questions, right? So I think at this time I was building my toolbox for how I would be able to use these tools to answer questions that I would be passionate about in the future. Right. And so another major part of this training were international experiences that I was able to have. Both Dr. Platt and Dr. Gleason were very keen to work and collaborate in international spaces. And that was definitely a plus for me, being able to go and actually see the people, that we're collecting samples from, people that we're working with, and understand, I guess, from just from living and being with people, what the impact of the research was. And so Dr. Gleason got a Fulbright fellowship to Addis Ababa, and I think this was maybe my third year in graduate school. And the title of this was Integrating Engineering, Biology, and Medicine to Study HIV in Children. And he asked if I would come along for 3 months to kind of help set up the lab and run some assays there. And so it was what the question we were investigating, or what we were trying to see, is if some of the low cost antiretrovirals that patients were using in some of the lower income countries was causing an increased risk for cardiovascular disease compared to some of the newer antiretrovirals that were being used in the States, or just being able to compare what patients were on in that Ethiopian cohort, right? And so basically, blood serum was taken from patients that had HIV, but were on various different antiretroviral regimens. And assays were done to characterize cardiovascular risk factors in based on each individual antiretroviral, right? And so, or inflammatory factors that are correlated with HIV. And another part of this work was looking at cathepsin activity as a biomarker for antiretroviral adherence. So a big thing also is trying to make sure that patients actually stay on the drugs and are taking them as they're supposed to every day. Because if a person that has HIV takes their antiretrovirals every day, then they'll have a suppressed viral load, and it's generally not transmissible. So at this time, yes, there are ways that you can detect if a patient is actually taking their antiretrovirals, but generally this testing is more expensive. And so what we were able to find is that cathepsin activity in PBMCs was a biomarker for adherence, and it is low cost compared to the other technologies that were necessary to really detect these antiretrovirals in serum. Right. So within Ethiopia, it was really a great experience for me. But it was a lot of learning, right, that needed to happen as well. So I'm in a completely new culture. There's a language barrier there. There are different, just customary things that are different as far as just politeness, where someone may tell you that, like, yes, and they're being polite, but it's just kind of like, you might need to hold off on that. And so I actually had to really learn. So it was definitely an immersive learning experience where I wasn't just learning the science. I wasn't just trying to help set up a lab. I was also learning the culture. And understanding how to communicate with people that were different than me, right? Also, there were limited resources. So a lot of the things that I took for granted in the States, I just assumed they would be there, and it would be easy to find things, but some things were much harder to find. And so really being able to navigate the limited resources and understanding really how intuitive, or not intuitive, but are innovative really in themselves they had to be to really circumvent a lot of these issues and still get research done. So just things of navigating transport and societal support of finding new friends, new community. I will say that my husband also traveled with me. We had just gotten married, and again, I don't know if that was the best for our marriage, but it was great to have at least one person there. And so he was there as well, and he also helped some with that transition of just being there and not necessarily having to be completely alone. But with those also came opportunities, right? So we were able to network very well with clinician scientists. And that's something that I had not been exposed to. And I don't think it's a normal exposure for most graduate students, unless maybe you're in an MD, PhD program. Right. Really understanding the health issues that were there within the Ethiopian community, and how they vary so much from what I was used to in the States. And I think this is something that I've just seen again in all of my global experiences, just the problems that we deal with in the States. Sometimes we only hear about those, but there are lots of other health issues or health obstacles that people are trying to overcome, opportunities for research, opportunities for innovation in other countries. And so just being able to really see that and understand, I think that just widened my scope, as well as just seeing, again, innovative methods for troubleshooting and being able to form a new culturally diverse community, right? So being able to find support, being able to make friends, and really just understanding just a different culture, being able to take things from Ethiopia back to the States that I would cherish for life, some things that I'd learned. right? As well as memories for a lifetime, right? So I think this increased my love for learning from a cultural as well as a scientific context, right? It was like, it's great to do the science, but for me, if I can also, learn something new, experience something in that space, then it was much of a more rich experience for me. Right. So another experience that I was able to have was doing an internship. So I did a summer internship while I was in graduate school. And this was because I was part of the cell and tissue engineering grant. And there was a requirement that I did an internship before I graduated. Right. And so because I had seen, again, these immersive learning experiences, and I had been able to attend a few conferences internationally with Dr. Platt, right? I had been to South Africa for a conference and Rome for a conference. And so I was looking at different places where maybe I could do this internship that could give me another international experience. And thankfully, I was able to apply for and receive the Whitaker International Summer Grant, which allowed me to go and work with this company called DISA Vascular. And DISA stands for Developed in South Africa, which was also a big deal for them because again, their major competitor is Medtronic, right? So they're competing, so they're making these cardiovascular stents and valvuloplasty catheters, right? And if they can make them right in country, then they can profit from these in country. Their country can also, profit from these stents. As well as they are actually communicating with the local community, right? They're communicating with the local cardiovascular surgeons. They know how well the stents are working versus not, and they can update design based on that as well. And so I just have a few pictures here of what that looks like, right? So one is of an abdominal aortic aneurysm, right? And here, the structure is compromised because of these atherosclerotic plaques, right? And so what you would do with the catheter is you can insert it into an iliac artery or through the leg, and you can insert uh, the catheter so that it can provide structural integrity or structural, yeah, integrity so that the blood vessel won't burst, right? And this is a way that you can kind of treat something like this or an abdominal aortic aneurysm without having to have invasive heart surgery, right? The other big thing that they made were these valvuloplasty catheters, which in the bottom right corner, where you go in to a calcified valve within the heart with a balloon. You can inflate the balloon, right, to help to remove the calcification. And that could either just help, or you could also insert an artificial valve there as well, right? So those were the major two things that was done there. And one of the things that I really enjoyed about that experience was because the company was so small, right? I was actually able to go and tour the hospital and actually speak to cardiac surgeons to see what kind of improvements they wanted made, or actually talk to them about some design considerations that they wanted us to take into consideration and to improve the design. And that was actually really, really cool. Just hearing their experiences of the actually using the device. And I'm sure this happens like in a Medtronic or whatever. But again, I would assume that if you're in research and development, you're in research and development. Whereas here, there are maybe 50 employees total. So you really get that experience of seeing, being in research and development, but also seeing the manufacturing facilities, seeing how, a small change in design actually has to get approved by all of these standard organizations, but how it also affects like the assembly line and everything like that. So that was also a really good experience as well. And so that also, again, showed me, again, a global perspective of just bioengineering, right? So I also saw that when you're looking at something from a global perspective, right, you have, again, different considerations. And with this particular internship, I saw, the raw materials that are available may be different. It may be hard to ship certain plastics, from the States or from Europe to South Africa. So what can we use that's cost effective, right? And I think even around that cost effective technologies gives lots of room for innovation, because oftentimes we might have something that we believe is, the best because it works, but in putting in a limited situation, there may be other alternative methods that could actually be used to help alleviate the same problem. And uh, you know, people might have a people may have like a handle on the market, or they might have a big part of the market, so it doesn't make sense to come through with a new idea. But in, again, some of these smaller settings, there's just room and there's just more room and space for the innovation, and the fact that it could actually be a really good idea for that context. So I finished up at Georgia Tech, and I would say that I received a top-notch training degree in biomedical engineering. I was an expert at this time, I would say, in HIV and cardiovascular disease, also a very strong molecular biology component that of what I had learned within my training. And this was me and Dr. Platt on graduation day, but I'd also had some other major life changes where I'd had a daughter who was basically born maybe a week before I graduated, and maybe 3 weeks after I defended my thesis. And so I was trying to figure out a place where I could be a scientist, as well as figure out what it means to be a new mother, and keep my sanity, right? So I was a bit burnt out by academia at this time. I'm sure pregnancy played a role in that as well, probably the emotions, as I look back on it. But I was thinking that somewhere in government, particularly the CDC, would be a good place, because, you hear that you get your good government job, and, it's maybe a little bit more family friendly. I would say that's definitely true for the CDC, maybe not so much. I don't know about the NIH, but it was a great place for me to kind of revive, or just get gather myself after these changes. And so that's what I did. I got a postdoctoral fellowship for 2 years at the CDC. And what I did there, I'm going to get a little bit more into the research here, just details here, but I really was looking to design tools that can accurately diagnose HIV, right? And so uh, it will make more sense once I get into the background slide. So I'll say that how I was able to do this fellowship, it was an ASM CDC postdoctoral fellowship in infectious disease. And basically you have to email or liaise with someone that's at the CDC to write a proposal for it to be accepted. And it can be really hard to actually get into the CDC as I saw once I was there. So this fellowship was an excellent way to kind of get my feet wet and kind of see what was happening within that institution. And I was working within the division of HIV and AIDS prevention. So I was able to keep some of my HIV expertise. I didn't do a complete switch like I did from mechanical engineering to biomedical engineering, which I was like, I will not make a leap like that again. So I was able to kind of use some of the things that I had learned to solve a problem. And so here, what I was interested in looking at was kind of how PrEP affects diagnostic testing, right? Or accuracy of diagnostic testing. So PrEP is a new preventive strategy where you take Truvada once daily, right? And this is an antiretroviral that people may take after they become HIV positive, but in this, you're taking it beforehand, right? And studies have shown up to 90% efficacy, right? But there can be breakthrough infections, right? So these are people who actually are taking PrEP, but even though they're taking PrEP, they still became HIV positive. And one of the questions we had was, how does this affect seroconversion and diagnosis? And I say seroconversion because the antibodies from the viral protein, so the antibodies are what are detected in an oral swab, and that's how you determine if someone's HIV positive or not, with these quick rapid tests that you would get like at a CVS or something. There are definitely more specific tests, but they're more expensive, and they're not generally they're not considered a point of care assay. So here I just have the HIV virus, right? And what generally we're looking for antibodies to are these envelope proteins, right? Your GP120, GP41, and GP160 are these two together. But what they found actually is that there is an increased false negative rate, right? So if someone was on PrEP and they were did become HIV positive and they came in to take the point of care diagnostic test, it might say that they're negative even though they're positive, and that was happening more for people that was on PrEP, right? And so my project really wanted to investigate or interrogate what exactly is happening. What are some of the dynamics of this antibody formation, and really with the end goal of being able to inform diagnostic design for better or improved tests specifically for this population. Right. And the way that I was able to do this was using samples from this Bangkok tenofovir study. Right. So this was a PrEP efficacy study among people who inject drugs. And there were over 2,000 participants in this study. And what they found was that for people that were on PrEP, there was actually a 49% reduction of infections in that PrEP group. And the way that they performed the study is that blood was collected at enrollment once at 1 month, 2 month, and 3 months, and then every 3 months after that for a max of 6.9 years or a mean of 4 years. Right? So they were tested during enrollment for HIV infection, right? So if they were already HIV infected, then they were not enrolled in the study. But if they were not, then they could be enrolled. And they were tested using the OraQuick antibody test, which again is a swab in the inside of your mouth. It takes like 20 minutes to come back, and it'll let you know if you're positive or not. And then they were tested monthly, and a nucleic acid test, which is the more sensitive test that looks at RNA positivity, was also done on antibody negative samples. So once you went in and you got the swab and you were positive via the swab, they went back to the previous collected samples to see if any of those were actually positive by the nucleic acid test, to kind of see what that delay may be between the nucleic acid test and the antibody test. And so, what my project really looked at was characterizing the responses of three of the, well, there are more than three, but I'm going to highlight these three analytes: GP41, GP120, and GP160. These are the most common ones that are used in antibody testing, right? And so, our assay that we have is a customizable assay that allows us to use patient samples, right? We have our, it's based on the Bioplex platform. So we have our samples. We can conjugate the protein of interest, and then we can incubate those with our patient samples, and then use the secondary labeled PE antibody to see how much of the antibody binds. And then we can also do an avidity measurement, which tells you how tightly the antibody is bound. And that is really that's a measure of how mature the antibody is, or how long the person has had the infection. So a more tightly bound antibody is indicative of a more long-term infection, whereas a more loosely bound antibody is indicative of a short-term infection. And generally, when we're looking at incidence testing, which kind of tells you it tells you how recently someone was infected. We look at the cutoff of 1 year, right? So has it been more than 1 year? Has it been less than 1 year? And that can also help with surveillance data and just prevention data, because if someone's been infected for a very long time and they didn't know, then you know the implications of that versus someone that was just newly infected. So we had 28 longitudinal samples in the placebo group, and then we had 14 in the PrEP group. And you can see here that GP120, so the blue thin lines are each individual person, right, in the placebo group, and the red thin lines are each individual person in the PrEP group, right? So we have this for antibody levels and then for antibody avidity. And lowest smooth lines were calculated to really give us just a visual representation of the data to see what the trends were between the two groups. But you can see that there's generally a blunted profile in the PrEP group compared to the placebo group for the antibody levels as well as for antibody avidity. And we see a similar trend for GP160 antibody and GP160 avidity levels, right? When we look at GP41, we don't see as big of a delineation between the two groups. And we explore this further, right? So this just gives us all of our data in one plot so we can see what's happening over time. But we did an initial additional analyses to really determine what the initial delay time was to seroconversion, right? As well as the longitudinal delay, right? So how long will it take from someone who actually becomes HIV positive to be picked up, by the point of care test if they're on PrEP? Is the question that we're asking. And so we did see a pretty big delay in the median time to seroconversion. In the placebo group, it was 56 days versus in the PrEP group, it was 224 days, right? So that's like a 5 to 6 month difference in delay for the time that these antibodies can be detected via a OraQuick test. And when we looked at it via our specific assays, the Bioplex assay, right, we actually saw that we lost a lot of our samples because sometimes the first NAT positive sample for some subjects was already bioplex positive, by some or most analytes. And what that means, so our bioplex assay, although it does measure antibody binding, it is more sensitive than the OraQuick, right? And so for some of the samples that we received, when the first NAT positive sample, so that's when it was RNA positive, at that sample time, it was already also antibody positive by our assay. And you can see if you look at this timeline here, let's say if someone became infected between this 3 and 6 month mark, right? Maybe they're RNA positive at month 4, and maybe antibody positive at month 5. But in between that, we can't see really what that delay is. And so we had some that were like that, and we had to move to a different type of analysis to really understand what was happening here and to get some data that we could use to inform the diagnostic test design. So what we ended up doing was doing a survival analysis, and that allowed us to really look using predetermined incidence assay cutoffs, which what I said before of a year was recent versus after a year was non-recent. So there are cutoffs that have been established based on patient data that has been previously collected that give cutoffs for what the antibody avidity or antibody levels should be at 1 year, right? So we were able to use those. And we were able to see that for GP120 and GP160, there was a significant delay in antibody maturation, as well as antibody levels for those that were on PrEP, right? Which again, it shows that for assay development, you may want to adjust the titer or adjust the cutoffs for these. Again, if you're specifically looking at people that are on PrEP, or maybe use a different analyte if possible, right? And so what we also wanted to do was see if this was a longitudinal change, like over time, does this hold true, right? So there's initial delay in this antibody maturation and antibody avidity, right? Does this hold over time? And what we saw for GP120 is that this is true, right? That the GP120, at least their antibody levels in the placebo group would stay higher over time than the PrEP group, right? But we were confused by this because we thought that we would see that there would be a delay in more analytes as what we saw previously in the first slide of data that I showed. And so what we went back to do is kind of look at adherence. Now, I talked a bit about adherence in the work that we did in Ethiopia, but it also played a huge role here, right? So when we actually went back and looked at patients that were adherent, and this was calculated by plasma levels of TDF that was in their system, it actually was only 8 patients that were in that PrEP group that were adherent. And so with that, we actually did see that there was a significant difference in those patients that were adherent antibody levels for GP160 versus not, right? And so this again showed us the role that adherence plays. However, right. However, there are other biological factors that could also play a role, right? So adherence accounts for some of this if patients are actually taking PrEP every day as they're supposed to, right? But there are other biological factors such as viral clade or other biological factors that are patient specific that could play a role into why the PrEP did not work or failed in those situations, right? And so we did see, so from this study, we're able to, again, characterize these responses, and these help us to inform future diagnostic strategies, right? So from the public health perspective, it was interesting to see, okay, there's a delay and it's not detecting it correctly, right? But the next step was, well, how do we detect it accurately, right? How do we accurately detect and diagnose people that are on PrEP, and how do we come up with different guidelines for testing? So from the CDC perspective, is like, what are the testing guidelines? And what should they be different for this population? And so just being able to see just the pipeline and how all of that worked. From there, I also had a project kind of trying to understand this using macaque models. And this came out of a collaboration, I'm going to go a little quicker, with James Smith, who was also at the CDC, and he did work more in novel PrEP strategies. And so he had a lot of macaque studies that used vaginal rings or just patches, just other modes of PrEP, right? And what happened for him is that he saw that he had one breakthrough animal. So in one of his vaginal ring studies, he had 7 pigtail macaques that he challenged with SHIV, and one of them actually did have a breakthrough infection. And so although they were using this this vaginal ring, and so he wanted to be able to better characterize maybe what was happening here. And so we collaborated together to be able to develop an assay that could actually look at the differences in antibody maturation, as well as antibody titers in the serum as well as in the vaginal fluid, right? So here it was also important for him to look at what was happening in that vaginal space, because that is directly where the intervention was happening. And we developed a platform to be able to look at this and also to investigate IgG and IgA uh, antibodies, right? And so the takeaway from this is just, yes, we were able to translate this by optimizing the platform, optimizing the protocol for vaginal fluid, how dilute does it need to be, generating bead sets, and all of these to be able to use this for future studies in macaque models. Right, and this is a bit of data just characterizing. You can see that there were some different different responses in the vaginal mucosal fluid versus in the plasma, right? But I'm gonna push forward. So these were the two things that I learned at the CDC, right? But while I was there, I also had some time again to rest, collect myself, and I realized that I actually did enjoy academia, and I miss students, and I miss teaching, and I missed having just that ability to be able to do my own research that I wanted to do, ask the questions I wanted to ask, and the sky is the limit. And so because I had been in government, I wanted to be able to, I felt that I needed to be able to transition a bit more into an academic space so that I could, again, get more feedback or more training just kind of on the grant writing. Things just work a lot differently in government than they do in academia. And I just felt that I needed to be in the academic space just for a little bit more before I transitioned to applying for professorships. And the Fulbright actually offered me that opportunity. I had been exposed to that with Dr. Gleason prior. I know that they support your family to go. I had another child while I was at the CDC. So now we're a family of 4, and it supported all of us to be able to go. And so that's what I did. Yeah, so the Fulbright. So the Fulbright actually also gave me a chance to switch skill sets. So I was also able to kind of see what I wasn't so strong in, or where I felt like the field was going, right? And I think a lot of the omics and bioinformatics and systems biology for me was tools that I could use that would allow me to answer questions more easily from this perspective. And so, what my project looked at was trying to really decrease maternal to child transmission of HIV, and uh, trying to look at the effect of BCG, which is it's a vaccine used for TB, but it's really the bovis strain of the mycobacterium that has been shown to be helpful in many cases. But in the case of HIV, it's shown to be very immunogenic, and can maybe upregulate certain T cells that are target cells for HIV infection. And uh, the study that I did, it was part of a bigger study between Dr. Jasmine and Dr. Blackburn, who were already kind of trying to understand some of these dynamics. And they had a cohort of infants that were either received the BCG at birth or delayed BCG vaccination, and they collected PBMCs for further analysis. And so my project or my training here was really using applied proteomics to assess systems level changes in the proteome, right, within the innate immune cell, and then also later to use um, uh, proteomics to really assess epigenetic changes at the histone level, because this had been something that had been previously seen as a mechanism, for this trained immunity is what it's called. And so uh, it was very interesting for me. So this study actually had to be modified quite a bit due to the limitation in the numbers of samples. But from this, I was able um, to determine ways to answer questions using in vitro cell culture techniques, and really form the ideas for the lab that I now have at the University of Florida. And so it was a rich training period uh, for me, where I was able to collaborate with, I feel like, the best and the brightest globally, because we had so many different seminars of people coming in from Europe and from Asia, from Africa, from the States. And they often wanted to meet with trainees and kind of give feedback on experimental design and things of that nature. And so it really just kind of gave me that space to be able to come up with ideas or things that I could be passionate about, again, within my own research space. And uh, also gave me experience with mentoring. Like, I was able to kind of manage my own small group there, ordering and figuring out just lab management in general, and passing on some of the skills that I had learned from my previous training, as well as being able to do outreach within the community and really see again the impact, of this research, or of these questions that we're asking on the community. Some of the youth that we mentored, like, had never really been in a lab. They came and they saw what I was doing and just the implications of that, and understanding just what the impact of HIV was, even in their communities, and just hearing those stories firsthand was really it was really just it hit me, hit my heart, right? It made me just it just made me excited to be able to do this research, to know that I could see, like, the impact that it would potentially have. And so what I'm doing now is kind of a combination of all of that now, really looking at chronic inflammation and things that cause chronic inflammation. These things can be the BCG that infants receive, or even things like bacterial vaginosis that can be drivers for HIV infection, right? Trying to see exactly how these correlate to HIV transmission, and using proteomics and bioinformatics and systems biology approaches to really assess uh, patient-specific differences, and really understand some of the mechanisms behind how these things are happening. Because if we understand mechanisms, then we can identify better treatments, we can have better prevention strategies. And so this is just the kind of the projects that I am currently starting within the lab. Yes, looking at this inflammatory activation by BCG and macrophages, understanding the role of the vaginal microbiome in HIV transmission, as well as downstream T cell target, HIV target T cell activation, as well as being able to use some predictive modeling to be able to really assess why some people are more at risk versus others. And with that, I will say that let's see. Right. So inspired innovation includes lived experiences, unique giftings, and expertise. And as opportunities arise, you figure out what you're passionate about and you realize what skills you need to answer those questions. And that's kind of been the road I've taken. You know, I'm really passionate about this. Maybe I can't answer these questions. I need more skill sets. And this will help, I think, to improve biomedical technologies, therapies, and strategies across the board. If we're all doing this, then like the world will definitely be improved and be able to improve the quality of life for patients. So that I'd like to say thank you to everyone that has given me funding over time, and UF as well, that has given me the opportunity to pursue this research on my own, as well as continue some of these international collaborations. And I'd say thank you.
Thank you so much, Dr. Parker. You are a true inspiration for all of us. So I just want to thank you all for listening to Dr. Parker. And now we are ready to hear from you. And if you have any questions, we can share it with Dr. Parker.